All right, today I want to speak on the arc length of an angle that's proportional to the radius. You want to show that the arc length of an angle is proportional to the radius. All right, let's start off with circles. We know from the previous lesson on similarity that all circles are similar to each other. Remember, a circle has no edges, no angles. So the only thing that's going to differ is the diameter or the radius. So some radius is going to be larger than others, some are going to be smaller, but still going to be the same shape. We often measure angles in degrees, but we can also measure in radians. What exactly is a radian? It has to do with the word radius. Remember, the radius is the same distance in the circle. You see that's our center there. A radian is a measure of an angle in terms of the radius of a circle. So let's take this angle here, let's call that theta. We'll say that equals, and this r here happens to be the measure of this arc. And don't forget about central angle. Every central angle equals its arc, intercepted arc. But let's say this measure is the same. They have the same measure. Then this is going to equal to 1 radian. Okay. Recall that the circumference of a circle is 2 pi r, and that the measure of a total circle is 360 degrees. We're going to use this to show that the arc is proportional to the radius. So the circumference is the distance around the circle, right? And 360 is the measure of all the degrees of a circle. See, all the arcs added up adds up to 360. So using the fact that theta equals 1 radian and that there are 360 degrees in a circle, we get theta is to 360. But remember, let's say that measure equals the same degree in radians in the radius. That is the same as the circumference 2 pi r. And this is to show that the radians is proportional to the arc length. And this concludes our lesson for today.